Okay, so we're going to do another example, one of the other studies that we did this semester, and it was looking at the flight risk assessment tool and how that might affect a person's decision to go or no go given a scenario. And so I'm here at forms.google.com. I'm going to open up the survey. And we got 13 responses for this particular survey, which is okay, it'll do. I wish there were more, just like the other one. And just real quick to summarize, this survey was a cross-country flight, and we've got a scenario flying from Merrill to Fairbanks through the mountain terrain. Will occur on a Sunday afternoon after work. You got 8 hours of sleep. And we get to Fairbanks because on Monday you have an important meeting that's for a job opportunity. You're given some weather information. It's not too bad, not that great, but looks good enough for a VFR pilot. And this is the route. And you're asked, as a participant, you're going to be asked the willingness to fly scale, right? This valid and reliable scale. Then you're shown this flight. The next set of questions, you're given another section, and it says, all right, use this flight risk assessment tool. So you're going to add your score, right? And then you're going to get a score from 0 to 24. The higher the number, the higher the numerical risk of this flight is based off this given scale, this table of like specific criteria to rank the flight itself, right? Given various risk. Then you're given the same scenario, same exact airplane, same exact weather information, all that stuff. And then you're asked what your score is and then what your willingness to fly is. And then the demographics are there. So we're basically trying to compare two groups or two sets of scenarios, the same group, so the same person is answering the survey, and you're comparing the responses from here's the scenario, figure it out on your own if your risk tolerance and your willingness to fly. Then you're given an actual scale with specific content and criteria over here using this flight risk assessment tool and seeing if that would actually change their willingness to fly now that they've given thorough thought into this flight. And what we're trying to measure is the effect of this flight risk assessment tool at the end of the day. That is the effect. That is the purpose of the studies, to see if this plays a role in decision making, if using a specific criterion-based tool like the flight risk assessment tool. And the FAA has one like this that you can download the app and kind of go through the scenario and then kind of get an actual score. And they rate the score green, yellow, and red, and then kind of helps you decide whether you'll go or not. So we're trying to see if this actually plays a role with the participants that we get. So we only had 13, which is fine. It just kind of shows us what we can, kind of shows the process of this, and then we can expand on that. And this is a good example of an actual study that is realistic. It's scenario based. It's you could also do this in real life in that sense, but this is a pretty good mirror of what would happen in a face-to-face scenario. So this is pretty close to a good set of questions and setup for this type of study. So we're going to download the responses here. So we've got this Excel sheet that comes out, and like I said in the previous one, I'm just going to go a little faster this time since I've already done this before. So we're going to delete these two columns, and I like to click on wrap text here so I can see clearly what these questions are. And here's the first set of the scenario questions that were asked without the flight risk assessment tool. So I'm going to insert a couple columns here to clear that up so I can separate and distinguish between the two sets of data. Here's your flight risk assessment tool, so I'm going to separate that as well. Oops. So I'm going to highlight a couple columns, hit insert, and then I'm going to select 3 of these guys and also separate them too. So now I've got some spacing between each set of scores. And what's happening here is here's each question of the willingness to fly scale, and what we want is an aggregate average. each of these numbers as a whole is one person's response. So what we want to do is find the average with no FRAT. So we're finding the average willingness to fly score without the flight risk assessment tool, that first scenario that we gave the individual. So we're going to find the average of that row. That's how I do it, equals average, and then basically highlight that it's this set of data that I want to average. I also like to highlight all the averages in red just so it's easier to pick out when I get to it again later. And I can just copy this cell, this formula, and paste it down this column of all the rows I want to get an average for. And there you go. And so now, if I like to get it to 3 significant figures or 2 decimal places, so I'm going to bring it down using this decimal reducer value here, decrease decimal right here. And so here you go. Here are our values, the average scores for each individual without the FRAT. And then what I want is the aggregate average of all those, because that's going to give me the overall willingness to fly of that group of people for the scenario without the FRAT tool, without the flight risk assessment tool. So we're going to select that. There you go. That's our willingness to fly scale. Average score for that group of people in that scenario within that group is 3.27 out of 5. We're going to do the same thing for when they see it with the flight risk assessment tool. What I'd also like to do though is get the average for the flight risk assessment score for the group of people that we got. And there you go. We have an average flight risk of 9.31. And if we look at the survey, 9.31 is in the moderate range. So it should theoretically, by our hypothesis, one of our hypotheses was that there would be a difference when they actually sit down and calculate it and see, oh wow, there is actually some risk associated with this flight. So let's do the same thing we did over here and find the average with the FRAT tool, right? So with the FRAT, we'll highlight that column and make it red just so it's easier to follow along. And we do the same thing, equals average, and select that row of scores. Copy this cell and bring it down, paste, and there you go. You've got yourself the set of data. And there you go. And now we're going to do the same thing. We want to know what the average score is for everyone that took this scale with the FRAT tool. So if we do the same thing, oops, there you go. Helps if I can spell. Select. And there you go. There is a difference. There's a slight decrease. There's a change in decision between people who saw the same scenario without the FRAT tool, and then they kind of seem to have changed their mind overall as a whole. As a whole, not everyone did. You can see, like for example, this individual, not too much of a change. But as a whole, there was a slight change between the two. And so what we can do now is graph it so we can visually see that. I like to graph things. It makes things much easier to follow along, and we can use that for the presentation. So no FRAT willingness score, FRAT willingness score. There you go. And then we'll put the average. I'm making a little table here. I'm just putting the numbers that I got from my analysis. And if I select these cells and now just highlight them, go to Insert and create a bar chart, there you go. You've got yourselves basically the effect of the flight risk assessment tool on willingness to fly on a given scenario, right? Willingness to fly. There you go. You can see clearly there is a change. Now, this could be a little bit arbitrary because theoretically, look at this. It's from 2.5 to 3.5. So that's really kind of not giving us a good representation. So I'm going to highlight that scale. And I'm going to go over here to the format axes. Go to this bar, axes options. Its minimum is only 2.5. So I've got to really make this 0. And there you go. Now we've got a clearer we'll make that 5. You can see that's now from there to there. 0 to 5 was what the scale was, and we're just going to make that 1. There you go. That looks pretty nice. And there is a change, but not that drastic, right? So we can say, maybe this doesn't really play a role with the willingness to fly. But there is a decrease. We could mention that there is a change, there is a slight change, but we don't know if it's statistically significant or not. That's later down the line. But we've got some visual representation that there is a change, a slight change in willingness to fly by using a flight risk assessment tool. So having a risk assessment tool can help potentially really have a pilot assess, is this flight really safe or not, with an actual criterion score. What I like to do is also separate the two colors. So I'm going to just change this. So I double click on this bar. I go over here to the format data point, go to this bucket, fill it with, let's make it orange. I like it. Blue and orange. There you go. So now it looks pretty clear. I also like to format this for later down the line. So if I go to chart design and make it where it's this guy, I like this one over here where it's a little bit gray in the background. Let's see here. Actually, let's change that. So you got different options. Excel's kind of nice about that. You can see what makes the most sense for your presentation. So I like this one the best. All right. Again, it's up to you. It's your design. So there we go. We've got one data set. We've got the average flight risk assessment tool, and this is something to discuss in your paper, that this is the result that we got for the average flight risk assessment tool. And then we do want to know probably the average age. That's a pretty good data point descriptive statistic to describe in your paper, right? So we want to know what the average age is of our participants. And here we've got the average age is about 27.6 years old. So the average age of our participants are 27.6. The other thing you want to know is how many male and females responded to your study, right? Since there's only 13, it's pretty easy to do. You can actually manually do this, but I'm going to show you how to do it in Excel again to count a set of information for a whole sheet. You could do this for a whole worksheet as to how many responses there are for a particular criteria, which in this case is the word male. Right, so the way to do that is equals countif. That's the function that we use, countif, and we select the range. You could select this whole set of data if you wanted to see how many of those cells has the word male in it, but we're just going to select the column that has the gender column for it. That's the range that we want, and the criteria is the word male. So we're going to do a string function. So we're going to say find out anything that has the word male, and I put it in quotation marks because it's string. So anytime you have words, you want to put the word within quotation marks, and it's going to find all the cells that has the exact word as male. We had 9 males. We can do the same thing for female. Zoom in a little bit here because it's starting to get a little small. So same thing, equals countif, and select that range. And the criteria that we want is the word female for that string. There you go. I put an extra space in there. So we had 9 males and 4 females. So there were definitely more males in this study that responded. Again, you can select, highlight that data, hit insert, and put in, let's say, a pie chart. Here, male and female. And you could find one that you like accordingly to for use of a for your poster. I'm looking for the word split, but it's not split. Gender. Let's keep it that gender. There you go. So 69% male, 31% female responded in this study. So what this tells us, in part of our discussion, is, hey, maybe we want to look and see that, hey, the males, because we've got more males, this might actually be different. It's not a very good representation of, the difference between the two genders. Maybe females might have a lower value, or might change this value different. Gender may play a role in this study is basically what I'm saying. That females may be more willing to see, oh, okay, there's a number here that says, hey, this is a moderate risk. I'm not going to go. I'm going to be less willing to go because of this, technical number. It just depends. And this just kind of helps us give an idea what this data represents, right, in terms of gender split of the results. We might want to do the same thing for the average hours. So our average hours. Because what that might tell us is, hey, maybe we want to look at if the experience level plays a role. Oops, something wrong there. Full average of these guys. So our average results, sorry about that. Right there, 222 hours is our average number of hours for our participants, which might play a role as well. You can do the same thing we did here for how many instrument pilots we got from our participants, how many commercial, private, and those are the three that we had. So again, we could do the same thing, count if this range has the word. And I can use, actually, since I typed this out perfectly on the left-hand side, I'll just click it. That's the word I'm looking for. I click the word that I'm looking for. There you go. We've got one instrument. And make sure that range is correct. That's 5 commercial and 7 private. So really we've got more commercial and private pilots than instruments. So maybe if we had more instrument pilots, this risk assessment tool might not even play a role because they're willing to just fly it because they can fly instruments and they can go into an IFR flight, IFR plan. So those are the things we wanted to see. But really what we're looking for is these two scales. And we've got some information here that we can use in our report. So we're moving along here. This is what we've done. We've now analyzed the data. Now we want to do some of the statistical portion. We want to see if there's a statistical significance between this 3.27 willingness to fly score versus this 2.7 willingness to fly score with the flight risk assessment tool. So here's where we use SPSS. Let me open a new data sheet. There you go. And we're going to copy over the average scores for all the individuals. If we had more, we'd copy all of them for the no risk and put that into the first column, or the no FRAT. And then we're going to copy it for all the scores with the FRAT, the average scores. Put that in there. We're going to label the two data sets so that we know what we're looking at with, nope, this was first of all no FRAT with FRAT. There you go. Now we're going to do the analysis. Because we used a Likert type scale from 0 to 5, we have to use what's called a Wilcoxon test. So it's a non-parametric test. So we go to Analyze, Non-Parametric Test. And in this case, we've got to go to Legacy Dialogues. And because we're not using two different groups or two sets of people to go from one set, let's say if we use one set of people for the first scenario and hopefully a similar set of people for the second scenario, then we do two independent samples. They're independent of each other, but they are related because they are the same person doing the two scenarios. So we're going to go to two related samples, click on that, and when we did our statistical analysis lecture, we did the Wilcoxon test type for this particular type of scenario. So we're going to use the same one. Put the no FRAT in variable 1 with FRAT in variable 2. Wilcoxon's what we want. Hit OK, and it's going to give us some information. right here. And really this is what we want, is this test statistic with the z-score and the p-value. This p-value is 0.06. It's greater than our 0.05 that we need. It's larger than that. Therefore, this is not a significant difference. It's close, but it's not significant statistically. So what we're going to say, and we could go to, if you don't know how to write this out statistically, if we go to Wilcoxon and then type in Laird, L-A-E-R-D, I love this website, kind of gives us a way of what the Wilcoxon test is, how to do it, and then an example of how to respond the report results of a Wilcoxon sign rank test. So based off these numbers, I'm going to give you one. I've created a basic setup here. So a Wilcoxon sign rank test showed that pilots were willing so in this case, because it's not significant, showed that there was not a significant difference in willingness to fly scores between let me see how I want to write this out, between fly scores when using the flight risk assessment tool versus without using it. Okay, a Wilcoxon sign rank test showed that there was not a significant difference in willingness to fly scores when pilots use the flight risk assessment tool versus not using it. Let's put it that way. That's better. Helps if I can spell right. There you go. And that's okay. It's okay to have a not statistically significant result, because that's just the nature of things. We didn't have enough participants. Maybe we could have set the data up a little bit better, or the survey a little bit better, but that's just the way it is. And that's what we have to report. However, we did see a decrease. We could report that there was a change in value between the flight risk assessment tool versus without the flight risk assessment tool. But here's the statement. A Wilcoxon sign rank test showed that there was not a statistically significant difference in willingness to fly scores when pilots use the flight risk assessment tool versus not using it. Then we plug in the z-scores from our statistics response, minus 1.84 and 0.066. So let's go back. Minus 1.84, and p is equal to 0.066. There you go. That's how you respond. That's it. So let's take a look at our ultimate goal. Remember, we want to make a poster and a final paper. So here we go. This is an example that I was doing before. And so you would change the title. We'd say pilot decision making using a flight risk assessment tool, or the effect of using the flight risk assessment tool on decision making. There you go. And you change the names to whoever is doing the study. So you'd add background based off your study proposal and the purpose of the study. You'd adjust this methodology to fit what you wanted to do with your study, and then what was predicted in terms of your hypotheses. What your, there would be no difference between the willingness to fly, and then there is a difference between the willingness to fly using the flight assessment tool or not. You could put in your graphs in here that you've got for your willingness to fly scores, and then you would respond by saying, there were 13 responses. I should say this: 13 responses to the study. Tell me how many males, females. age, certificate types, any of the descriptive statistics that we did over here, our average age, our average hours of the responses, and you can even mention the average flight risk assessment tool score that was given from your participants. And then you would go into your findings. So you say the findings indicate that pilots are less willing to fly. That is what the results said, that the results showed that the pilots were less willing to fly given a flight risk assessment tool when measuring a flight that was of moderate risk, right? So you could write that down somehow in this statement right here. And then you'd plug in the Wilcoxon's sign rank test. So this whole statement right here would just define whether it was statistically significant or not. So you'd copy this over and paste that in. You can put some images in if you'd wanted to. If you wanted to show what the flight risk assessment tool is, you could use a portion of that from our survey. So we can go over to our survey and take a screenshot of some of this and put that into here to show what it looks like. And then here's where the main meat of the study is, the limitations in future research. Well, we were limited because of COVID and a couple other things that we weren't able to really get as many participants. And then you've got to really think outside the box. What are some of the things we could do with our future research? So we could say with the flight risk assessment tool, we could give different scenarios to see how they respond. You would get different groups of pilots, you might look at different criteria of pilots, only look at private pilots, only look at commercial pilots, only look at instrument pilots, but tell them that you're not on an IFR flight plan, things like that. So you're now limiting, to see, in terms of the data, we're just going to try and find participants that are private pilots and see if there is going to be a difference. So now you're going to be able to look at classifications to see if that plays a role in the difference to fly based off a flight risk assessment tool. Maybe you'll adjust the survey to be a little bit more on the higher end of risk that may not come across as risky in the first place until they actually analyze it with the flight risk assessment tool. So we are limited based off the scenario that we made. We might want to change these scenarios or give multiple scenarios, make it a longer study with more surveys to see what happens, right, and compare to different groups. That's what you really need to discuss in terms of your future research. Furthermore, discussion is really where the important part of this. It's like, why did you even do this study, right? The discussion is the main concept there. So the findings, unfortunately, you could say the findings unfortunately do not support the hypotheses due to the significance not being statistically, due to the results not being statistically significant. However, the study does show that there was a decrease in willingness to fly score given a flight risk assessment tool being provided. What does this let us know? This tells us that the flight risk assessment tool changes the decision-making process in the pilot. So we want to see how that really plays a role. And if it does play a role and we get some professionals on board and we discuss, okay, was this flight risky to take, really risky to take and not worth taking, and that flight risk assessment tool really plays a role in a go, no-go decision, then that's one way we could, potentially advertise or promote the use of a flight risk assessment tool. So that's where the discussion plays into role. What you're doing is you're inferring, making inferences from the results. What does the results really tell us, or what can we think outside of the box with respect to the results? What can we discuss with respect to the results? What does it really affect us in terms of aviation? So what does that really do? And that's how we are going to respond to that. And that's what you're going to make is this poster. And what I'd like to do is have each individual of the group so what you work together to finalize the poster, but I'd like you to make your own discussion on the poster. So if you go on PowerPoint and you go to Insert and go to Audio and Record Audio, what you're going to do is about a 5 to 10 minute basically elevator speech or presentation on this poster. So you're going to record it. You're going to say, this research study was the effect of the flight risk assessment tool and pilot decision making. You talk a little bit about the background, the purpose of the study, and how the study was done. Then in your own words, you're going to talk. Don't just read the poster. Talk about the results and how these results can affect aviation as a whole. So that's what I'm looking for, is a final poster with a presentation on explaining the study and what it really means to us now that we've done the study and gotten the results. So that's where we're going with in terms of the poster and presentation. And then you're going to make a final paper, and this is what it's kind of going to look like is a final paper. You're going to have an abstract, and what I want you guys to do between the two of you is select who's going to write what and try and split it evenly. And if it doesn't seem like the other individual is really helping you out, I want the colors to reflect that. If you end up having to do the whole thing on your own, submit it on your own with one color. Make one individual write in blue, one individual have their font in red, and then that way I can see who wrote what and grade accordingly. And so we can skip the introduction. What I'd like to have is significance. What's the significance of the study? What can the study really tell us? The limitations and delimitations of the study. You can skip the background and the literature review because that was done in the proposal by one of you in the team, and that can be skipped. If you don't mind just copying over the research question and hypothesis so it's all in one place. You can talk about your participants, how many participants ended up being there. Actually, no, skip that. That's the methodology. That was part of the proposal. You can go right into data collection analysis and the results and kind of tell me what happened with the results. Just put in your graphs, what the study was doing, what the results were statistically. And then the biggest part is the discussion, so discussing what the results mean, what the limitations in future research might be. In this particular example, this was too short. I would like this to be expanded. What can you do to make this research more robust in the future? Redoing the study, right? So what would the future research be? Like I said, maybe find specific categories that you're going to research, either just private or just instrument or just commercial. Maybe look at different experience levels with hours or type of experience, things like that. And then a conclusion and the references. And that's what you're looking for. That's the study.